Hello, you're welcome back. All right, so we will continue from where we stop. All right, so here we're going to be looking at problems and solution on projectiles. So I'll be picking some questions. All right, so I have some question here on the screen. Okay, so the very first question goes this way: a ball is projected at an angle of 30 degrees. Okay, to the horizontal is thrown with a velocity of 20 meters per second. So evaluate the following time of flight, maximum height, and range. So we already know the formula, okay? Starting with time of flight. So the time of flight of the projectile is given as 2u, then sine theta, then divided by g. So this is going to be equal to 2u, 2 times the initial velocity, which of course is 20 meter. The sine angle of projection, which is 30 degrees. Okay, then divided by g. Constant acceleration due to gravity, 10. So this is going to be equal to 40 times sine theta is 0.5. Then divided by 10. 40 times 0.5 is 20. 20 divided by 10, that's 2. So 2 seconds. Alright, so that is the time of flight. Then for the maximum height, we are looking at u square sine square theta. U square sine square theta, then divided by 2g. Okay, so that's gonna be u is 20 square, then sine square 30 all over 2 times 10. Pardon me. So of course 20 square is 400. Sine 30 is 0.5. Then you have to square sine 30. So that's going to be 0.5 square. Okay, then divided by 20. So this is going to be equal to 0.5 square is 0.25. So I'm having 0.25 times 400. So what does that give me? Okay, 0.25 times 400, that should be, let me get a calculator. This is 0.25, right? Then I'm having 0.25 times 400. Then of course that's 100, okay? Then divided by 20. So that's gonna be 5. So 5 meter. Then here we go with the range. The range of the projectile is u square sine 2 theta, then divided by g. So that's gonna be 20 square sine 2 times 30 divided by 10. So that's gonna be equal to 400. 2 times 30 is 60. So I have 400 sine 60. Then divided by 10. Okay, so that's gonna be equal to 400 times 0.866. Sine 60 is 0.866 actually, then divided by 10. Okay, so 0.866 or 87 approximately, 0.87 multiplied by 400, right, then divided by 10. So that's approximately 34.8. So 34.8 meter. Okay, so I hope that is well understood. Okay, so now Let's look at maximum range of a projectile. Okay, at what angle will a projectile be projected? That's a question. Okay, in that niche. A projectile will attain its maximum range when the angle of inclination is 45 degrees. Of course, to get range, for range to be maximum, to get a maximum range, then you must project that projectile at an angle of 45 degrees. That is the only time you have a maximum range. Why is that? Why? Because for range, what we have is u square sine 2 theta. Okay, now the sine of theta, sine theta is actually maximum only if theta is maximum. Only if sine theta is maximum. Okay, you get sine theta to be maximum only if theta is 90 degrees. So in a case where, in this case, the theta is 2 theta, all right? That means for me to get sine 90 at this, okay, here, then the theta must be 45, because it's only when I multiply 45 by 2 that I have 90 degrees. Okay, so please take note, for us to have a maximum range, then the angle of projection must be 45 degrees. All right, so I believe there's still another question I need to solve. Okay, so this is a question. It goes this way: a projectile is fired from a ground level with a velocity of 300 meters per second at an angle of 30 degrees to the horizontal. Calculate the time it takes to reach the maximum height. This is the time to reach the maximum height, not the time of flight. Okay, I hope you know the difference. The time, that's going to be small letter t. The time it takes to reach the maximum height is just simply u not okay. Just use sine theta, then all over g. Why the time of flight is 2u. Okay, so in this case, it's just the time to reach the maximum height. So here I'm having 300 meters per second, okay, as the initial velocity. So that's 300, then sine 30, then divided by 10. So this is going to be equal to 300 sine 30 is 0.5, then divided by 10. So this is going to be equal to 0.5 multiplied by 300, that gives 150. 150 divided by 10, that's 15. So 15 seconds is the time it takes that projectile to reach the maximum height. All right, so that's another question here. Okay, this goes like this: if a projectile has a maximum range of 36 meters, find the speed of projection. So the maximum range, the R maximum, according to the question, is 36 meters. And we know that at maximum range, the angles, okay, the angle of projection at maximum range, for us to have maximum range, is 45 degrees. Okay, so let's put the value there. R maximum is equal to u square s sine 2 theta. All right, so that's going to be sine 2 times 45, right? Then divided by g, which is 10. So we're looking for the initial velocity. That's what we're looking for. U is the question. So our maximum is 36. Equal to u square, then sine 90 divided by 10. Sine 90 is is 1. Okay, all I just need to do is to cross multiply. 1 times u square is u square. Then if I cross multiply, that's going to be u square multiplied by 1 will give me u square. Then 10 times 36, that's 360. So for me to get my u now, which is of course is the initial velocity, I'm going to find the square root of 360. Okay, so what is the square root of 360? So 19 approximately. 19 meter per second. That is the initial velocity. Alright, so that is that for this video. Okay, we'll continue in the next video. See you in the next video. Thank you very much.